It's definitely my favorite developer conference. I love the kind of marrying of all these different topics and like seeing all these folks in person, both people I've met on the internet in real life. It's a super energizing place to be.
Well, this is actually my first time at Universe. It has been awesome. Not only the event and how it looks and feels, but the people and the energy, like everybody's really excited to do really nerdy things. And that's kind of my favorite thing.
The community is really great. There's all different types of people. Everyone obviously really loves the GitHub platform. And we're all here for essentially just making ourselves better and more productive.
I came here, I got open source, and I got a fresh new deck. I'm loving it. It's great. It's fantastic.
The conversation, the number of different topics that you can talk to people about. We literally just had a question and we're talking to some of the GitHub experts about it and solve a problem we've been working on.
Seeing the vibrancy of the community, the colors, even just how things are portrayed and the little gifts that I have a programmable name tag. I love all these quirky little things. It speaks to the community of just how nerdy, but also fun and interactive. And I think it's a really just cool vibe to be around.
I've spoken at many conferences at this point, and most of them are more corporate driven and quite a bit just louder, frankly. But here I've made friends with many people. Everyone feels approachable, and I feel approachable too, and I've really enjoyed that experience so far.
I've always been interested in contributing to open source projects. What's a good way to get started? Love that question because there's so many good ways to get started. You could get started by just helping triage issues. So many open source projects have issues where the maintainers, they don't know if it's a real bug or not. A lot of repositories also have what are called good first issues. Home Assistant is this cool open source org. In Home Assistant, look at that. They have 2.9K issues. Do you see that? They have so many labels. That's amazing. Good first issue. Aha! They've already got some here where it's like, this is a good first issue for you to take on and fix. And also generally just thinking, what are some projects that I use, that I care about, that I might be able to help with?
Hello, everyone. Welcome to Open Source Friday. Welcome, welcome. Happy Friday. You made it. You made it. It's now October 10th, and I am so happy to be here today with you. I'm bringing you an amazing project, and I think all of you are going to be very pleasantly surprised with the possibilities. So my name is Andrea Griffiths, a la Colombia Dev in all places, and I get the privilege of coming by and talking to you here today. Oh my gosh, I'm seeing friends on the chat already. Friends, please go ahead and holla if you have used the Julia programming language before. And if not, if you're curious, please let us know why you're here. Let us know where you're joining us from. I'm joining you from Florida, all the way in the South. And again, it's my privilege to be with you today. We have talked about Julia Lang before here on Open Source Friday. Many years ago, we had Logan Kilpatrick. Remember Logan? He came over and gave us a couple of demos. And then we had a really good friend of the GitHub community and of open source in general, Miguel Raz, came this year to, I believe it was in Spanish, we did a stream about Julia. Just amazing folks are part of this community. It's a big community. And then we have folks like you who are coming because you're curious and you want to learn what it's about. Congratulations to Learn 0418 who says they had a PR merge. Hey, congrats. So happy for you. That's awesome. That's what it's all about. And I'm thrilled to have an opportunity to come to you here live and talk to you about Julia programming language. So this programming language set out to solve one of the most frustrating problems, I guess, in technical computing. For those of you who've been around for a long time, maybe you've heard about this before, the two-language problem, where you're doing prototypes in one language, and then you gotta rewrite it in another for production. So these folks, these amazing people I'm gonna be bringing on stage, set out to figure out why did you have to make a choice? Why choose between productivity and performance? Very much like the meme, why not both? So they set out to create a programming language that solved this problem. And today we have the dream team with us, and I'm going to start bringing them in. We had Viral Shah, welcome Viral, who's the co-founder and CEO of JuliaHub and co-creator of Julia. Viral, welcome, welcome.
It's great to be here, Andrea. Thank you for having us.
Actually, Dr. Shah. Look, I'm a stickler for titles, okay? So I missed that. I missed that.
Thank you, but also you should not use that again.
Okay, so let's go with Viral then.
Perfect.
Thank you so much. Perfect. And next we have Stefan Karpinski, who is co-creator and co-founder, also co-creator of Julia, co-founder of JuliaHub, and you're an award-winning for numerical software. What is the Wilkinson Prize for numerical software?
I mean, it's a niche prize because it's for numerical software, but it is one of the top prizes in that area.
Amazing.
So yeah, there's really, if you're in numerical computing, you've heard of the projects that tend to win the prize, like FFTW, which is a great FFT library. I can't remember some of the others, but they're all pretty well known for people who do numerical stuff.
Amazing.
Yeah, and we had the honor of winning. I guess it was 2019 for the creation of Julia.
Well, congratulations to Viral as well and to the rest of the co-creators. That's amazing. Well, welcome, Stefan. Thank you for being here.
Yeah, thanks for having us.
Let's bring up Jeff Bezanson. You are the CTO and co-founder of Julia, co-creator of Julia, and of course, also a award winner of the Wilkinson Prize for Numerical Software. But welcome. Thank you for being here.
Yes, hello. Thank you.
And please let me know if I should say doctor or not.
Just Jeff is fine.
Just Jeff is fine. That's the best about this community. Amazing. All right. And finally, we have Mr. Keno Fischer, who is CTO of R&D and co-founder of JuliaHub. You are a core contributor to the project for over a decade, which is amazing, and had led optimizations for the Celeste project, which is the first petascale application in a dynamic language. And I hope you explain to us what all of that means.
Happy to. I'm very happy to be here. Thank you.
Amazing. Well, thank you all so much for being here. Like I said, we have talked about the language before in the show, and we have friends of the show like Miguel and Logan come by. But this is such an incredible opportunity because we get to dig a little bit on the history of the language as well and get to know you a little bit better as co-founders and co-creators of the language. But then also we get to talk about a bit of the enterprise side of it. We get to talk about JuliaHub, and we get to see demos. And what you folks don't know who are watching is that while we were setting up behind the stage, the word AI came out. So there's going to be a little bit of that. There's going to be a couple of demos that this team is going to bring and share with us. So I'm thrilled for all of us to have an opportunity to learn a little bit more about Julia. So for folks who are new to the Julia language, and maybe Viral, if you can take this two-language problem, and I covered a bit in the intro, but why did you decide personally that this was something that needed solving?
Yeah, this is, this goes to the origin story of Julia, right? So, all of this came together back, at least, all of us have our own sort of reasons for having started Julia. But for me, I had come off my PhD building a parallel MATLAB implementation for solving large graph problems. And it was extremely frustrating to not have control of the language and or the parallelism that we were working with. And I, caught up with Stefan, who was in grad school with me at that time at UC Santa Barbara, with Jeff, who I was working with, and Alan Edelman, who was on my thesis committee. And we just started talking about like, hey, isn't it so frustrating that you have these amazing mathematical languages like R and MATLAB when it came to doing writing algorithms, but then you have to rewrite everything in C for high performance. Wouldn't it just be amazing if you sort of had the best of both the worlds? And I kid you not, we had an email exchange about this. And 3 days later, Jeff had the first working Julia parser, most of which actually survives to this day, 15 years later.
No, but not for long.
But not for long. It is finally getting replaced.
What's happening? Are we changing?
It's being replaced. Yes, it's been rewritten.
It's finally been rewritten in Julia itself instead of it's been in Lisp for this entire time because Lisp is just a great language for writing parsers.
This is amazing. So you reached the moment of inception now, where the tool
Yes, exactly.
the language will write the language. I love it. I love it. I love it. That's amazing. Okay. So obviously, and you mentioned MATLAB, and there is a lot of folks who are here. Maybe they're in academia or they're researchers. They have very concrete sort of use cases for Julia. Why do you think that nobody thought of this before? If it's been, something that's been a problem for so many years, like what do you think was the challenge there? It took the four of you to get on an email thread to get it kicked up.
Seems that way.
So the idea has always been around, right? That R came from a language called S, which came from AT&T. MATLAB came from Cleve Muller's work, at Stanford and elsewhere. But the thing was that people always thought that high level languages had to be dynamic and could not have compilers, and they had to be slow. And if you wanted high performance, you had to rewrite everything in C. So there was incremental progress over the years in this direction. And I think we are the first folks to have come up with, the first folks who have taken the next step, right? And Julia not just runs on all your CPUs and everything, it also runs on GPUs, right? And it really is a step change in that direction. But I think maybe either Stefan or Jeff might be better suited to say more about some of the languages history.
Yeah, well, I mean, Common Lisp got very, very close, right? Common Lisp was very, very close to being this language, but people basically just didn't like the syntax. That's very important, and there's a lot of other detailed reasons. You could speculate all day why people aren't writing everything in Common Lisp to this day, but it didn't quite work out for whatever reason. Partly historical, I don't know.
I mean, that's interesting how you arrived to that too, where actually you solve your own problem in a way, which I think that's how a lot of open source projects are born. Then it's had some incredible evolution. Like this is even though I mentioned academia and research, this is a programming language that's used in production at small projects you might have heard about, like NASA, the Federal Reserve, big pharmaceutical companies. So Julia is being used everywhere. I'd love if one of you could share some of the spaces where you're seeing Julia being used, and then maybe we can take a look at an intro demo for folks who are, I know, itching to see it in action.
Yeah, Keno, maybe this would be a good time to talk about some of the HPC stuff.
Yeah, sure. And I think in general, Julia is used anywhere where people have, difficult numerical data analysis, simulation sorts of challenges. I know you mentioned the Celeste project in the intro. That was a large scale astronomy application. So we were analyzing astronomical images on supercomputers, basically generating from images catalogs of what objects are visible in these images, and lots of data coming off of these telescopes. So this ended up being a large-scale HPC application running on hundreds of thousands of cores at a really large computer out at Lawrence Berkeley National Lab. But that's just the high end of application. Julia runs everywhere from your Raspberry Pi to those really large-scale machines. As Raul mentioned, it runs on GPUs, it runs on it runs on whatever hardware you have, and people are using it for everything from science to just playing games on their local machines. So
I think it's worth adding that in addition to Julia, and maybe this might be a topic for another podcast for you, Andrea, but we have Chris Rackauckas, who is the creator of Julia's scientific machine learning, or the SciML ecosystem. And it's a comprehensive set of over 150 packages that are focused on solving deeply scientific problems. And it's the kind of ecosystem that doesn't exist in most other languages, and it's also the foundation for many of our products like Dyad and Pumas.
That's amazing. And yes, please, I would love an intro so that we can have that conversation. Thank you. All right, so I think most folks that are watching, maybe they have heard of the language, maybe they didn't think they had a need for it. Everyone always has a need for better performance, friends. So I think if you didn't know you need it, you're gonna find out why. But I'd love if you could take us through a quick intro. And I can't remember which one of you is gonna do that for us. If you could take us through a quick intro and maybe share your screen, that would be phenomenal.
I think I can do that. Yeah.
Thank you, Stefan. That would be awesome.
Let
So
me
wait,
share my
how old
screen.
is Julia now? 15? No. Yes. 15.
Well,
Wow.
we started the project in 2009, and then there was sort of a few year period of a year or so of just kind of messing around and figuring out what we were doing. And another couple of years once I think at some point we realized this is serious. We really want to give this a try, which is it's a little bit of a weird superposition because you think, okay, this is never going to take off. Come on, this is just a project for us, but at the same time you're earnest about it. So we really gave it a
Right.
shot and worked for very hard for several years. Um, and we started getting some traction, a little bit of traction, in the sort of 2011 era. And then by 2012, we really had gotten it to the point where it was, worth announcing. And then things really took off.
And we were
Um,
really lucky that Alan gave us that much time.
yeah.
They were like, we need to experiment for about 3 years before we know what to do here. And he was sort of like, okay, which was very, very, very lucky.
I love
Mhm.
that. And great things take time, right? And great things happen to those who wait. For people who are in that position right now, I have to ask this real quick. Where was the moment where you decided, okay, what changed? Like between 3 years of hacking at it and the four of you working on it, like what pushed you to say, okay, finally this needs to be out in the world and we're gonna kind of dive headfirst?
Well, I mean, I wanted to get to the point where you could just write some code that looked very easy to understand, very easy to write, but then run it and you got, very close to C performance. As soon as we got to the point where we could show that, I felt that was something we could demonstrate and people would be interested.
Yeah, we
Amazing.
sometimes go back and see sort of like the early evolution of Julia, and it is impressive that how back even in 2011 or 2012, we had sort of all the fundamentals in place, and you could do so much that already showed the promise of what we're doing. The long journey since then has all been about sort of productization and making it robust and scaling to industrial problems and scaling up to HPC, scaling down to embedded, scaling into other scientific areas, and sort of meeting the unreasonable. Like we started out, this was a phrase that Stefan always uses, so allow me to steal it, Stefan. But we started with our own unreasonable demands, but then we grew Julia to meet the unreasonable demands of other people over the years, and we continue to do that.
That's amazing. That's amazing. So and it's grown now. That needs to be a t-shirt, a sticker, or something on
Yeah,
your
we
site.
like to be greedy and unreasonable. That's what.
Yep.
Oh my gosh. Yes, with the logo. We like to be greedy and unreasonable. I love it. And listen, it's working. Now you have over 1,000 contributors. It's grown into a community of its own. So there are many greedy and unreasonable people willing to work on this project.
That's right.
All right.
Yeah.
Let me share your screen, Stefan.
Okay.
And then if you keep zooming a bit, there is over 1 million users of Julia. Wow. The user base is over 1 million.
Yeah,
incredible.
that's what we estimate. It's hard to estimate with open source projects, but we would estimate that there's about 1 million users.
That's incredible.
Yeah. It is incredible. It's amazing to us that we've gotten to this point. It's been a wild ride.
Lots of people to file bugs.
Yes, that's true. Lots of bugs to be filed. Well, I mean, I think Bjarne Stroustrup said he's the creator of C++, that there's only two types of languages: the ones people complain about and the ones people don't use. So everybody's got a bug about something. That's always the case.
Absolutely. That's phenomenal.
All right, let me fire up a Julia REPL. So an interesting thing about Julia, if you're coming from a compiled static language, you may not be familiar with the most common way of interacting with Julia is probably starting an interactive session. So you type Julia. You have to have it installed, of course, but I'm not going to walk through that. Everyone can go to the website and it's easy to do. So this is a development version because I'm in my development directory. I'm actually gonna go somewhere else so that I can get a more standard version. This was just released yesterday. It is version Julia 1.12. You can see we have a little ASCII art logo. Jeff did that back in the day, and then we based the graphical logo actually on the ASCII art logo that came first.
That's delightful.
So yeah, so we can, you can use it as a very basic calculator. That's great, very useful. You can do compute 2 pi. You can do a little bit of I think we kind of pioneered this, typing backslash and then a LaTeX. If anyone is a mathematician, they've done LaTeX typesetting. And then you press tab and it puts 2 pi in there. And you can do all sorts of things, like there's you can do pizza. You can use the pizza emoji as a variable name. Not terribly useful, but kind of cute. And people do regularly use this for things like, let's say I have x sub 0 is my, a variable that I have. People like naming their variables the way they have the variable names in a paper or something like that. So that is a thing people, myself included, legitimately use all the time. So just to give a feel for the language, I'm going to do a really old classic example. It's a numerical language. So one of the superpowers that it has is that you can define your own types that are just as efficient and powerful as the built-in ones. In a lot of languages, integer or float is special. And in Julia, that's not the case. They are actually defined very much, in the bootstrapping process. They're defined for you when you start up the language. It would not be very useful if you didn't have integers, but they're defined using the machinery of the language itself, and there's nothing preventing you from making an equally efficient integer type of your own. So here's an example. I'm going to define a modular integer type. And to define a new type, you introduce it. There's a couple different kinds of types you might want, but the most common is a struct. By default, they're immutable. That means you can't change the fields once an instance is created. The type is named modint. It has a type parameter called n, and that's going to be the modulus that we're working in. It is a type of integer, and subtyping integer here means you inherit a lot of behavior that is defined generically for integers in the base language. And then it has a field here called k. So that's the actual value, and it's of type int. So we're wrapping a normal integer, and we're going to make a special integer with different behavior. And then we provide a constructor for it. So you have to have a way of making one of these things. And this signature here is just sort of how you define when this thing can be called and what it can be called on. This is the type here, just like the type declaration at the top. And this is the argument that you call it with, the thing you want to take, that's going to be the value you wrap. I'm not going to get into the where stuff, but it's for the type parameter n. You need to introduce the fact that it's a type parameter. And then the actual construction just uses this special function inside that says new, just creates it just says create a new instance. It's familiar from many other languages, that type of concept. And then the actual thing you do is you reduce k mod n before sticking it in the field. And then that's it. Now we can create one of these guys. So we can, I'm going to do mod 13 for my example. So this big integer mod 13 is just 3. And this, I'm going to define b. So now this big integer mod 13 is 12. Okay, so that's cool. We defined a type and we created 2 instances of it. The obvious thing we want to do next is do something with them, like add them. And that's going to error because we haven't told, this is a brand new type. We don't know how to do anything with it. The only thing we've told it how to do is construct a new instance of it. All right, so in order to add, so this is where the very Julian flavor of things comes in. We're going to import the commonly used base function called plus. So we import it. And that lets us add methods to it. And so this is a little wild. Methods, if you can ask for the methods of plus, and it's going to give you a very long list of methods. There are lots of things that know how to do plus. And unlike a class-based object-oriented language, plus doesn't, there's not a plus specific to each first argument. These plus methods are specific to each combination of arguments, and the most specific one that applies in any particular case is used. And sometimes there's fallbacks for like, well, I don't know what to do with this thing, so maybe there's just a very generic definition. Okay, so now that we've imported that, we're gonna define a method for it. So here is, we're just gonna define the method, and I'll walk you through what this means. We're saying that plus with two arguments, a and b, where they're both a mod int with a type parameter n. And this where n says that n is a type parameter, not some binding from the outside scope. The definition is just, well, I'm going to add the two k fields and then apply the modded constructor to that. So this is a very simple definition. To do modular arithmetic, all you do is you add the values, the wrapped values, and then you reduce modularly again. But now, as soon as we do that, we can do this arithmetic. So remember, a is 3, b is 12. In modular clock arithmetic, a plus b is 15, but 15 reduced mod 13 is just 2. So okay, it worked. We can, all right, what else can we do? Can we do multiplication? No, we can't do multiplication because we didn't tell it how. But, we're just going to go ahead and tell it how to do some of the basic operations. So we've defined multiplication exactly the same way, except it's times instead of plus. Subtraction exactly the same way, except it's subtract minus instead of plus. And then negation is just, you negate the value inside and wrap it. Okay, so now suddenly we can actually do a bunch of stuff. We can do a plus b, a times b works, and you can check the arithmetic. This gives you the right answer. A minus b, negative a. We can even do a squared, a to the, some very large number. And this is efficient because, we have a nice efficient algorithm for implementing power generically. And the result you get isn't enormous because it's modular arithmetic and it reduces down to a small number. Okay. So far, so good. The way we print these things is a little annoying. Maybe we can do something about that. So you overload the generic show function. So there's a show function that is how the system knows how to print stuff. And so here we define for an IO object and a modular integer, how do we print it? Well, okay, there's this get compact thing. Details, but basically sometimes you want a compact printing of something and sometimes you want a more verbose. So in the compact setting, we just print k. In the more verbose setting, we say k mod n. And so now we just print a and it's a nice 3 mod 13, nice and clean. And we'll see the compact setting in a moment. We'll define an array of modular integers. And so I generated random numbers from 1 to 100, 5 by 5 of them. And then I applied this constructor to it. And now I get an array of these modular integers. So now you can already see some of the composition that's happening in the language, right? Like there's this matrix type, and I constructed an array with these modular integers. Not only that, these modular integers are represented very efficiently. They just take the space of an int. They're immutable. So an array of these is represented in the efficient way that you want to have numeric types represented. And we can already do things like squaring this matrix, raising the matrix to a really big power, and it's super fast. This is doing an efficient algorithm as well. And it does modular reduction for you. So now you already are getting to the point where like, oh, we can do useful stuff in modular arithmetic with just a few like very simple definitions. We're missing a couple of things, like A+1. We would like for that to work. So it doesn't know how to do this mixed arithmetic. And there's a cool system we have in the language where you can do promotion and conversion. I won't get into the details of it, but it's a really fun little bit of language design. So you just define these two pretty simple rules. And now suddenly you can do A+1, 1 plus A. Doesn't matter what direction it is. You could do, A plus, I don't know, let's say I had a weird integer type like a unit 8. It doesn't know how to do that because I only define the rules for modular integers, or for the int type specifically. But we could make these a little fancier and have them work with all kinds of different types. Here you can see now we can mix different types and we get exactly the results we want. And another thing that I really can't avoid, I should really have to show, is that Julia is, it's cool that you can define these custom types.
Mm-hmm.
And I already alluded to the fact that it's represented efficiently, but also the implementation of operations on them is just in time compiled and is very efficient. So, and we provide a lot of nice tools for how to inspect that. So here's an example. So let's say we can show the LLVM code. So we use the LLVM compiler library, and we can show the LLVM code for the addition of these two things. And so if anyone's familiar with LLVM code, this is it's like a virtual machine language, like, assembly, but it's higher level and is compiled down to actual assembly. And we can also show the actual assembly. So this is the actual assembly language on my laptop that we generated for this operation. And it's a little, our modular arithmetic actually does more than I would like, because it checks for, negative values and handles them correctly and does a little bit of like overflow checking and that kind of stuff. But still, this is a very small handful of instructions. Another very cool thing that I realized,
Stefan, I was wondering if we should, in the interest of time, move to the next stage of the demo.
Yeah, let me just show you one
Let's
last
do that.
thing.
No, this is fascinating though, because the composability is crazy. And for folks who don't know, like just in time, the fact that the compiler sort of picks the right method, like it just picks it for you, right? Very cool. Okay, what are we seeing now? Sorry to interrupt.
So one last thing that I realized is cool is that the code is actually specialized on the modulus. So if we do a modulus that's a power of 2, like 16, we get different code that's much more efficient. So instead of doing a modular reduction, it does an AND with a constant value. So I realized that, just before this one, was like, oh, that's a cool demo. So this is a very, this is part of the secret sauce to like how Julia gets its efficiency. And this is actually all my intro demo. I think this gives people enough of a feel for the language that we can probably talk about other stuff. So
amazing. Thank you so much. That was awesome.
Yeah, of course.
That was awesome. Okay, I do want to make sure that we talked about your package ecosystem, because you built that into the language from the beginning, right? But before we do that,
well, not from the very beginning.
Well, not from the beginning. Okay.
There was a brief period of time around 2012 where we started there was no package system, and we just the repo started getting bloated because all the packages were just like files in the main Julia repo. And at some point I was like, oh, okay, this is getting out of control. We need a package manager. So I, ran off and spent a month or so building a package manager.
And now you have over 10,000 packages that are part of that package ecosystem. That is very cool. Okay. And then, so now it's built into the programming language itself. And I understand why you build it now, because that file system management was not the way.
Yes.
Let me go back to, as I saw a question about LaTeX compatibility and any kind of integrations there, and I want to make sure that I bring it up. Friends, if you see it, pop it up for me, because I don't, and I'm sorry, I should have highlighted it, but if you ask the questions about LaTeX, please come back, come back and post it again, so it's kind of top of my feed. But
I think I saw the question, which was just,
did you, Keno? Yeah, would you mind?
The Unicode input was fully LaTeX compatible, and the answer is no. It's just the same names for the same characters, or a name for every character that's in Unicode. Obviously, some LaTeX things are not. However, if you do want full LaTeX, there are obviously packages that provide things like string macros to give you full LaTeX support for things like plot labels, or if you just want to put LaTeX strings into various objects, there's package support for that. But the base
there's a cool package called LaTexify that takes a Julia expression and formats it as, renders it as LaTeX. It's very cool. So you can get really nice labels just from, like, I wrote an expression which I can evaluate, but I can also render. So
very
it's
cool.
pretty handy. Yeah.
So Andrea, I was thinking, like, I wanted to make sure we do cover a couple of other quick demos, because so Stefan covered the very early days of Julia, like what the language design was like, and now we could move to the release. Actually, this we just released Julia 1.12 like a couple of days ago. So
amazing.
This is the launch party right here.
I love
and
it.
Jeff is gonna show us some of the very cool new features of Julia 1.12 that people have been asking for many years.
Yes. So as Stefan said, traditionally we've focused a lot on interactive computing, which is great. I love it, and also really by the same token, people can also just as easily start up the Julia runtime with a script and run, say, like a backend service using it, which is really just pretty much just as easy. So people do that as well. But a lot of people expect a different workflow. People want to deploy binaries or build shared libraries, like like you would from C, to use from other languages, or just because that's how your deployment works. So people have been asking for that for a long time, and it's been taken a little bit for us to sort of adapt everything to that kind of a different deployment method. But we're pretty much there now, and so we have this new tool. Let me demonstrate.
Awesome. Yeah, if you don't mind sharing your screen, and congratulations on the release. It's a couple of days old. You're right. This is a release party.
Let's see. Can I do?
You should be able to see the little plus sign. Yeah, it's coming up now.
Perfect. All right. Is that working?
Yep. You are now. I see your terminal. Perfect.
Okay, great. So we have this new tool that's called Julia C. So the naming convention is like the C stands for compiler. So it's the same naming convention as like GCC or Java C or Rust C. Now we have Julia C. And this is also showing that another new feature is our package manager can now ship apps, which are top level command line apps, as well as Julia packages. So we have here, I've got, it's one of these apps. So it installs here in my .julia bin. I've got this executable Julia C that you can get now, and so you can just see the what the options it has. It makes it very easy to generate an executable library, etc. So you can see the options we have. There are probably going to be a lot more of these over time, but basically you can, if you want an executable, you can just say output exe. So for example, I've got your basic hello world here, hello.jl. It's just a simple main function. It takes command line arguments, which is a vector of strings, unsurprisingly, and it just prints something. And so now I can just give this to Julia C, and I've got this. We have this other new feature, --trim, which basically tells us to please, remove any code that is not needed by the application. So we have an entire new system for doing that, for making smaller executables. So I can just run this. And it just takes a few seconds. It takes a little while, but it's not that long. And there we go. It ran. I've got hello. So you can see as of now, it's about 1.5 megabytes, which is big for Hello World. It's a lot bigger than your C Hello World, but this is actually huge progress for us, because the way the system works, we tend to we like to put everything together in a big giant ball of all the code you'll ever need. So we traditionally have had sort of larger, pretty large kinds of binaries and deployments. Which on most modern machines doesn't really matter, but people want to be able to have small executables. So we have so this represents very, very major progress for us. So and this I expect this to come down a little bit over time, but for now, a megabyte or so is not too bad. So that should be reasonable to most people. But of course, you run it, you get you get your Hello Worlds, and there's also the output lib, so you can also build a shared library to, say, call from Python or wherever. We also have this very handy -- bundle option, which will basically create a directory that has all of the dependencies you need. So all of the external libraries you might be calling will all be bundled in there, and then you can ship that whole directory somewhere, and everything should work, hopefully.
That's awesome. Okay, and so that's the new flag, the trim save, and now you can go ahead and build these standalone executables that are tiny. I think that's a lot of credit. One, you're like, I'd like it to be smaller, but 1 meg is that's 1 MB is pretty
This was
impressive.
the number one feature that people have asked for like at least for the last 5 years, if not longer. So
that's right. Yeah.
We've actually been able to build standalone bundled executables for a while, but it was a situation where it was like 300 megabytes or something like that, and people would be like, wait, that's not what I meant. Right? And sometimes that's acceptable, other times it's not, right? So this really unlocks and opens up a lot more application areas for the language. So
amazing for your deployment scenarios. That's amazing. And for folks who program in other languages, I love drop in the chat what a hello world would be. I love to know what it is like on Python and go. I guarantee you it's not that little. So
yeah, you wouldn't believe the amount of discussion it took to arrive at that @main syntax.
Really?
8 months of discussion.
I mean, it's one of the things we've learned about programming language design is that, especially if it involves syntax, you can have years of discussion to get to what's seemingly simplest thing possible. But
I mean, yeah, the amount of iceberg that is underwater with these very simple things is just really unbelievable. I mean,
it's a feat of engineering. So I think the next demo should take us to the world of AI, because everyone's talking about it. And
yes, the future is now. Let's do it.
Because how do you write large Julia programs now that you understand the basics? So, Keno.
Yeah, perfect. So I figured what I would do, and let me share my screen while I set it up. Okay. Okay. 1 second.
No worries.
I may need to restart Firefox to.
That's completely fine. If you have to
back
pop
in about
out,
25 seconds.
If you have to pop out and pop back in, Wilson decided to bark in the middle. He did not say hi. That's the pet of Open Source Friday. And today I thought he was being good, but he had to come back and say hi. Well, Keno comes back. There were a couple of folks who were asking how they could get involved with the project. And maybe we can quickly share how people can start contributing.
I mean, I would say the first thing to do, obviously, is download and try it out.
There you go.
The next thing I would do is, get on our Slack. There's also a Zulip instance, and some people are on one or the other or both. The four of us mostly hang out on Slack just because we use Slack for work as well, so it's convenient. But it's a really, really nice, welcoming, and helpful community. That's by far the easiest way to get quickly involved, is to show up there and start listening to what people are talking about and chatting with them and asking questions and making comments.
And we've got the good first issue tag, as introduced in your intro
exactly.
video. We've got
yeah.
it.
Amazing.
We've been on GitHub since 2011. We're one of the first large scale projects, I believe, to have adopted GitHub. And from day one, the project was fully
You
built
guys
on
were
GitHub.
skeptical, but I was pushing
Yep.
it. I was like, I pushed
Yep.
these guys to use Git, and then I pushed them to use GitHub, and they're like, "Do we need this?" But we did. We needed, because before that, our Git hosting was a Mac Mini in a closet in California somewhere.
Yeah.
So this
Listen,
is way better.
that's another feat of engineering right there. Thank you.
Yeah.
You've been GitHub native from the start. I'm sure
Yeah, and
that's
that's
shaped the way that the project has grown a bit too, right? Like,
and you've
hey,
got
Oh,
the
but we
it's
didn't know
tremendously
that.
helpful.
and you've got the entire commit history on there, all the way back to the initial empty commit is all still there
Yeah.
Amazing.
on GitHub.
Amazing. I love that. I love that. For those of you who like enjoy the archaeology of these things, go get in there. Go take a look. All right. I think Keno's back. And I can see your screen now. So take it away.
Perfect. Can you hear me also? That's always the danger of leaving. Okay, perfect. Yeah, so what I thought I would do is, I would like to do a little bit of a demo, but I figured people have mostly seen, Cloud Code and these sorts of agentic tools, and they are very good at writing Julia code. So what I wanted to do is I actually wanted to mostly talk about sort of my workflow when I use these tools and how I use them with Julia. Just because I think that when people talk about using AI for development, the workflow that they have has a very significant impact on how successful they are actually getting value out of these tools. And I think what I've come to realize is that there's sort of three things that you need for high productivity use of these tools. One is you need to give the tool the right context. So it needs to know either what the code base or the issue or the relevant logs. Two is that it needs to have what I call loop closure. So it needs to be able to independently validate its answers. So that means either compile the thing, run the tests, or have some other way to know whether what it's doing is correct. And then the third thing is sandboxing. So basically, to accomplish this, I've written myself this little, or actually the AI wrote for me, this little Julia project I call Claude Box, which just pulls, it uses all of the tooling that we have in Julia for sandboxing and for building binaries. So, I mean, I don't know if people are familiar, but one of the things that we really do in Julia is that we want to provide an out-of-the-box experience. And one of the key ways we do that is that if you have any binary dependencies, like you're depending on a plotting library, you're depending on the CUDA stack, you're depending on any sort of numerical library, we will build binaries for those for you for all major operating systems. And then we will ship them to you along with your Julia packages. And that provides a really nice experience for people using Julia, because they just get all of that out of the box. They don't have to fiddle with apt-get to install some library in addition to their Julia packages. We just ship those all for you. So this thing I've written here is basically using that same sandbox mechanism to set up compilers, to set up all the libraries that I need for Julia development inside a sandbox, so that the agent has loop closure, as well as making sure that the agent can't just RMRF my home directory, which it does sometimes try to do. So for example, let me do something like clone Julia and add a new test for Julia C. I mean, that's what Jeff just demoed, right? So this is the kind of thing that I would do. And then, as you can see, I run it in sort of bypass permission mode. So usually when you use Cloud Code, it will go and ask you permissions for everything that you do. But if you actually want to experience the workflow, that's too slow because you have to pay attention to it. So by sandboxing this inside with all of the sandboxing stuff that we have, it actually can just, I don't have to worry about whether it's going to delete something or make any mistakes. It can fully trash the entire file system. And as soon as I quit the session, it'll go away. And yeah, that's just using the same infrastructure that we have for building binaries, which we've done for a long time. The other sandboxing that I have is I actually have a GitHub sandboxing. So the AI agent has access to its own GitHub organization, where it can, create repositories, delete repositories, do whatever it wants. And so I can just tell it, to create repositories there, clone repositories there, and you can sort of see all of the things that it's done. It's created 2 copies of the Julia repository. Probably not necessary, but again, it's mostly about sandboxing and allowing the agent to run autonomously. So, I didn't really plan for what this demo would show, because every time you run it, obviously you get a different answer.
Right.
But you can sort of see that it found the relevant files. It sort of found the trimming feature. It decided, okay, maybe a good test. Maybe a good test would be to do Fibonacci, and then it wrote some make files, and it's actually, it's a reasonable way to go about this. So I've actually found a fair bit of success using these AI tools on Julia. We're doing some work to make it better. So as I mentioned, loop closure is super important, and that includes things like error messages in the language. If the error message is confusing, humans sort of get used to mapping confusing error messages to what it actually means.
Right.
But the AI agents, they're starting from scratch every time. So if it gets confused by an error message once because it's confusing, it'll get confused by it every time. So we've gone through and started fixing error messages. And we're also starting to do things like building RL environments for specific behaviors, so that future agents will be able to get trained on those and improve their performance on Julia. But in general, it's very, very good at Julia code. All of the major models are. So both.
And
both
if it can edit a make file, sold. That's
That's your test. That's your litmus test. Amazing. This looks incredible. Hey, I have a challenge for you, the team, or everyone who's watching. I need you to make this, package it up, but for Copilot CLI, please, so that I can play with it too. Which, I mean, technically, we should be able to do that.
Well, you ask Copilot to add that feature to my package. Like the package that I have that does all of the sandboxing was entirely written by the AI. That was sort of the challenge was, okay, can the AI lock itself in a sandbox?
You know what?
There's no backdoors, so maybe I should do that.
This is a good. This will be a good do it live and stream. Just set the agent loose and be like, okay, come back to me and add it as a feature. That's awesome. And I did share the repo. Keno, that looks amazing. I love how you're thinking ahead of how you can incorporate this, and you showed us a real, like, this is your workflow. This is it's a way for people to use it.
I use this every day. I wanted to pull up my Claude usage, and then saw that there's some things in there I can't share on stream. But I basically have like thousands of dollars worth of API credits if I didn't have a subscription. So I have this basically open in a window, and there's some things it's good at, some things it's not good at. So I sort of have one screen where it's working on the things that it's good at, and then I'm manually working on the things that it's not good at on the other screen. So that's been basically my workflow.
And that is absolutely the dream right there. You're creating your own dream team, yourself and your agent. So I like it. That's awesome. So this is a good glance into the future and the fun things that you're experimenting with. Great for folks. Listen, the project itself, the package is MIT. I just saw the license. So go ahead and fork it also, and just adapt it for your own whatever agent you're using. Very cool. Very cool. Okay. Well, so we've seen a bit of history. We've seen what's new on the release. Congratulations again to the team for the release, and a glimpse of the future of how you can incorporate agentic workflows into creating this sandbox and actually testing out and getting it eventually to do all the wonderful things you wanted to do and not bother on it. Let's talk a little bit about what's next for Julia. I'd love to know, in terms of course, the programming language itself, what's on your roadmap. But maybe before we do that, we should talk about JuliaHub, and we should talk about something that you're doing now, because you're tackling a whole new problem with a new, it's a new project, it's a new programming language.
It's yes. So Andrea, I think you're talking about Dyad, which is descriptive.
Yes.
Which is a descriptive language that is built on top of Julia for modeling and simulation. So, maybe I'll just, say a few words about it. And I've shared with you a link of a very cool agentic demo for building a braking system. So what happened for us as a company is that, we are sort of focused on building Julia and its ecosystem and all the wonderful stuff you just saw. But as we matured as a company, our customers kept asking us about, hey, can you build higher levels of abstraction with modeling and simulation tools? And we would often tell them, hey, Julia gives you superpower, so you can go ahead and replace these old expensive modeling tools with something modern and new that'll run on GPUs, that has all the automatic differentiation, all the fancy capabilities. And they've turned around to us and said, can you build that for us, and we would like to buy it from you. And that's how we started building tools like Pumas in the pharmaceutical industry. For example, if you got the Moderna vaccine, that was the modeling for that was done using Julia under the hood.
Thank you.
And in partnership with this company called Pumas AI, we were approached by Boeing for their interest in, like they would like to build models of entire planes that are high fidelity, that are very scalable, where the embedded software can be easy to program. And as a result, we started work on Dyad. So Dyad uses all of the cool compiler capabilities that Jeff showed, for example, in order to build models that are fast but also compact, create small binaries, can be deployed on embedded systems, and so on and so forth. We feel the world of systems programming is antiquated today, and Julia is a breath of fresh air for that world. One of the cool things, and this ties into what Keno was just showing with the agentic experience, is that if you look at Dyad, it's a descriptive language for building physical models. But the major leap forward that is happening right now is that the chat-based interfaces are becoming the new human-computer interaction for engineers who are working with models. And when I say engineers, I'm talking about industrial engineers, like mechanical, chemical, process engineers, folks who are traditionally not users of GitHub, but through our tools like Dyad and Julia, we're bringing this whole new community onto GitHub. And we expect that the HCI will be such that the user talks to the model, talks to the computer, the model gets generated in the agentic frameworks, and then you can visually see what the code, what the model that the AI built for you. You edit it by hand, you make it better, you do a sign off, or the engineer's always doing the sign off, and then you complete your product design. And in some of the demos that we've shared, we found that if we're seeing at least 10 to 100x, at least a 10x, but potentially 100x productivity improvement in the time it takes engineers to build new products, right? So we all know about how AI is helping software engineers build, new applications very, very fast, but it wasn't clear what this will do for hardware. And what Dyad is showing us, especially with its agentic capabilities, is that these same tools, but customized very heavily, by JuliaHub, by the Dyad team, are actually going to revolutionize the development of systems and hardware. And we are very excited to bring these products to the market. I don't know if you have a way to share the demo that I shared with you or added to the links, but it's the YouTube.
It's in the comments. Yeah.
Yes, I have posted.
Perfect. Thank
I have
you.
posted the YouTube link, and I posted also, I think the blog post article announcing Dyad. This is fascinating. Like, you created Julia to solve this specific problem in scientific computing mostly, and now you're like handling or tackling hardware rather, bringing all the best parts together. Fascinating.
One thing that people might ask there is why wait, another language? And we did think hard about that, and there is a lot of the underlying technology. You can build these models in pure Julia. There's a system called MTK, which stands for Modeling Toolkit, and you can build you can use Julia as a sort of macro DSL to write these models. But at some point, you kind of want more constraints, right? Like when you're doing modeling stuff, a lot of the stuff shouldn't be imperative. It should be declarative. And you also want to do things like check units, make sure that the connections you've made actually make physical sense, and do that type of checking that can actually be done statically, if you design a language specifically for that. So that's one of the reasons. Another unique thing about Dyad is that there's a one-to-one correspondence between the code, the textual representation of a model, and then there's a graphical representation too, because a lot of software engineers are super used to let's work with the code. The code is a good way to do things. We can version control it. We can check it into GitHub and roll back anything we want, or review stuff. But engineers love working with these graphical systems, where you can kind of like take a component, connect it to another thing, drag it around, see the diagram, reason about the diagram. And we wanted to bridge those two worlds, bring them together, kind of like we solved the two language problem. Now we're solving the sort of the two community problem in engineering. And so you can go, there's a one-to-one correspondence, you can each view is equally good, right? You can have one person working on the code, and you can have another person then, immediately dragging around and working with the graphical representation. And it goes immediately back to the other side, so they see the same thing. And another side benefit that has been tremendous is that LLMs are very good at working with text, right? That's what they do. They're not so good at working with diagrams and pictures. So if you want to be able to apply all this AI technology that exists now, you really need to have the back and forth, the one-to-one correspondence between the text that the LLM can manipulate and the graphical representation that is familiar and useful to the engineers. So you have this incredible hybrid workflow that this has enabled, where you'll ask the LLM to generate me a model of like a cargo bay door on a plane, and it comes up with something, and you look at it and you're like, oh, okay, yeah, that's pretty good, but I kind of want to tweak the diagram. And you can go in and edit the diagram, and then you can ask, at some point you get to the point where you don't want to work with the diagram anymore. You want to tell it to do something else. And you can just say, hey, can you modify this and do something else with it? So you can go back and forth with an AI, working collaboratively on this graphical model, which is just it's an incredible experience. It's a really powerful tool.
Amazing. I think hardware engineers are gonna be so pleased, because this is and I love how you frame it. You're not saying, it's not better, it's different. It's a way to sort of bring the same power that software engineers have with Git and CI/CD tools and AI, but now give that power to hardware engineers. And this is fascinating.
Exactly.
This is amazing. Amazing. Okay, so folks, Dyad is created by JuliaHub. Viral, we didn't touch on what JuliaHub is. Would you mind explaining a bit about that? And for folks who are this is their field and they're interested in digging into bringing hardware engineering into this new era of AI, what's JuliaHub? How can we connect there? And let's get a bit of overview of that.
So, JuliaHub is, along with the name of our company, it's also the product that the company built. It's a cloud application. It's a cloud product that is meant for running Julia applications in certified environments, in safety critical environments, or largely regulatory environments, right? So like drug design, or if you're building an automobile or an aircraft,
aerospace, that bay door, right?
Exactly. So it's a cloud platform that makes it easy to run Julia programs, and the big part of the platform is a feature that's called the time capsule. So a lot of cases, a lot of times in regulatory environments, what happens is 10 years from now, a drug is on the market and now there's a side effect, and you need to now go back and see how the modeling was done in order to sort of figure out what to do next. And regulators often want to go back and review the data and review the code, review the models. And JuliaHub is the platform that makes all of that possible. So not only can it do the time capsule, but it makes it easy to develop programs in Julia, run applications like Pumas and Dyad, scale them up, apply AI techniques using GPUs and so on and so forth. So it's largely an enterprise tool. We also, it also makes it easy for package developers in the open source ecosystem to register their packages once they build them. So it provides a lot of the package development workflows for regular Julia developers, whether they're in open source or at companies. And so it's really sort of, think about it as a developer productivity tool that brings the best of what you have in the open source development domain, but inside of companies. Kind of like GitHub Enterprise, Yeah. Stefan, maybe if there's anything you want to add to that.
No. I mean, we've been doing enterprise, cloud software for a while, and this is a sort of new phase of it. So that part is actually very well developed. And the dyad part is newer, but also like really, really well developed and cool.
Cool indeed. I love this. Okay, awesome. Thank you so much for that, Viral. And then if folks want to figure out what JuliaHub can do for you, just go to JuliaHub.com and reach out to this team. This has been amazing. I've learned so much. I think folks in the audience are also equally appreciative. They learned a ton about high performance computing from just using Julia over time. Thank you so much, Sagar, for that comment. And thank you to everyone who's tuning in. I'm going to do a quick scroll back, and folks that are still here with us, every time I tell someone it's going to be 45 minutes, it's a lie. And this was a really interesting topic to me. So I was fascinated. I mean, thank you, Viral, for keeping us on task, because I basically defaulted to the audience. I'm like, yes, show me more. But thank you so much. I think we covered a ton. We covered the past, the present, the future, what you're working on next. Also, what the new programming language diet can do for hardware, a bit of JuliaHub. Is there anything else? I think there was a question about the futures that are planned for Julia 2.0. Anything that you can share there when it comes to roadmap? And then maybe there was one more question from the community about the community. And then I promise you folks, you can go enjoy the rest of your Friday, kind of holding you hostage here. But that wasn't it. It was this one from Abul. And thank you, Abul, for being here. What key features are planned for Julia 2.0? Anything as public roadmap that you can share? And then anything that can address current limitations in GPU support?
I think I'll take some of that, and then others can chime in. I think at this point, we don't have any concrete plans for a big Julia 2.0. I mean, I think originally when we released 1.0, we sort of thought that we'd do that again. And for folks who were around, that was a very painful process, because we made so many changes in the language and just deprecated everything. And you just see deprecation warnings scrolling down your screen every release. I think at this point, the language is too mature for us to be able to do it again in that way. So I think what we are thinking of doing instead is figuring out ways to do more gradual evolutions for both APIs and syntax to sort of allow people either to declare or to opt in to those kinds of changes, so that we can gradually make those improvements. I think there's various things in terms of big features that we'd like to work on. Obviously, the Julia C work that's been going on that Jeff demoed is a big driver, and it's working now, but it's still experimental. And there's some tooling missing to really help you understand, okay, when will this actually work? When won't it work? And in particular, if it doesn't work, why didn't it work? So more tooling in that direction. I think some tooling around interfaces and sort of checking correctness of code is something that we're very interested in doing. Julia was always designed to make it as easy as possible to get, do really amazing things. And I think now we'd like to make it easier for people who have these large-scale production Julia applications to make sure that if they're working with a big team, or if they're working with AI agents, just extend make it easier for them to make sure that those changes are correct by adding some sort of interface support.
I think we're going to be able to do basically everything we need to do without a 2.0. So I'm not sure it's really necessary. I'm very curious what the GPU limitations being mentioned are. I'm very curious what that's about. But I think that's definitely, whatever it is, I'm pretty sure that's something we could address without a 2.0. But I'd be curious to know what he's thinking there.
I mean, we have a very active collaboration with NVIDIA in both the open source community as well as sort of, JuliaHub as a company working with NVIDIA. So, we are constantly, working on it. But please chime in through the regular open source channels asking for what you really want to see.
This is the best. That's the best part of open source. Like, we get to say it. So folks, go be a part of the community, join the community. I share the link to where you have all your links for your Slack and all the other places. And then you can chime in and help shape the future of Julia. Okay, thank you so much. I think we have one final question from the community, and this is a friend of the show, so we have to answer it. And Miguel, thank you for the question. Is there a community or influence that you believe Julia would have benefited from being closer to during its development? Time machine question. If you take it back, is there?
Yeah, that's interesting.
We did have a lot of interaction with the Jupiter community, which this is not a should have, but that was a really fruitful and really lovely interaction.
Yes.
We got invited to SciPy a bunch of times and went and gave talks, and it was a really friendly and inviting community. Sometimes people view Julia Python as this like, oh, it's like this clash, but we've always gotten along super well with the SciPy people, and the actual developers are lovely and helpful and very generous people. I think it's more of a perception. And the name Jupiter was actually picked because it's Julia, Python, and R. So it was meant to be like, oh, hey, we can support all these different languages.
What? That's a piece of lore I did not know. That's awesome.
Yeah,
Very
it's pretty cool. I don't know. I mean, language communities we vibe with that seem cool, like, Rust is a great language that seems to have a good community, and but they weren't around, or at least they weren't
They're
they
sort of
weren't,
co-developed,
it
developed
was
at the same time.
founded around the same time.
Yeah,
So I don't know
they're
what could
about
happen
pretty
there.
much the same age as us. Yeah, an excellent project. Yeah.
Yeah, exactly. Well, thank you so much. And that's an interesting question, Miguel, because that definitely is interesting to see, like, for all of you who are, this might not be the last programming language that's invented, right? Like, there might be somebody now that's
surely
an
not.
email
It would be a tragedy if it was.
with their 3 friends talking about, hey, can we fix this thing for ourselves?
We admire Rust and its community very, very much. Yeah, absolutely.
Yeah. So hopefully at some point there's some people who are, sitting around being like, oh, this old Julia and Rust stuff is terrible. Like, we got to make something new and better. And they'll come up with something super cool. That's the way these things go.
And
Looking
that's the
forward
beauty
to
of
it,
open
we can
source.
finally
I love
retire.
it. No, Keno, you're not done yet. There's a lot to be done yet. Friends, thank you so much for being here today. This has been absolutely delightful. I learned a ton. And thank you for building Julia. Honestly, Viral, Jeff, Stefan, Keno, thank you. Thank you for spending the time today. I mean, it's been 15 years from that first commit, I guess. And now you have thousands of contributors, thousands of packages, and you're tackling the agentic era in a way that's super interesting. The things that the hardware proposition bringing, I'm excited. My brother is an electrical engineer, and he does a lot of diagramming for like the big, like, think of like the MTA, how electricity on the subway kind of thing happens. And I'm thinking about the way that he does the modeling for that. Very archaic. This might be the future of that.
That is exactly what we as a company are hoping to bring into the new era.
Yeah, no, excellent. I mean, I seen the kid at work, and definitely version control and other things can be powerful for him. So super excited to share that with him personally. And then also for all of you who are intrigued by this proposition for software and hardware, take a look at the ad. Very, very interesting stuff. So if you're watching this and you're thinking, I should try this, give it a go. You might fall in love. This might be your jam. This might be your new favorite programming language. Go to julialang.org. You can download it, try it out in your browser. You don't even need to install it to take it for a spin. Check out the ecosystem. You have a very robust package ecosystem, tens of thousands. So if you're thinking of starting to build something from scratch. Maybe somebody's already done the thing for you. So go take a look there. And then, of course, if you want to contribute, join the community first and get a feel. It sounds like all of you are very active on your Slack channel too. So the few people I know from the Julia community that are contributors are all very lovely. So based on that assumption, I can say that it's a lovely, welcoming community. So join their Discord, their Slack, their Zulip. And yeah, all the links are there at Julia.org, julialang.org/community. And thank you all so much. Anything else that you want to leave us with?
I think, Andrea, you've done a fantastic job covering everything. So I think,
thank you so much for having us. It's been fun.
My goodness.
This was fun. Thank you.
Yeah,
Thank you all.
Much.
Thank you, Viral, my unofficial co-host of the day. Keeping me on task. Thank you all so much. Please let this not be the last time that you're at Open Source Friday. We need to chat. I need you friends to come to Universe. Like there's exciting possibilities. So love to work more with you and the team. Thank you so much for being here. Thank you for taking the time. I think there's a lot of folks that maybe did not even know what Julia was, and maybe they'll go in and become active users and contributors and keep this lovely ecosystem going. So thank you all so much for being here. I appreciate you.
Thank you.
Thank you.
Bye, everyone.
Bye.
Bye. How cool was that? See, like, this is like my favorite kind of nerding out on an Open Source Friday. Thank you all so much for being here. Thank you, Miguel. Miguel, I owe you a call, a message. It's been a wild, busy time because we have GitHub Universe coming up in the next couple of weeks. I appreciate all of you who turn in, and I appreciate all of you who are going to go and give Julia a go, right? So again, it started as trying to fix a problem for a very specific reason, but you can use this in scientific computing and data science and anything and everything. So take your frustrations into this beautiful language, and maybe you can find some peace there. And I thank you all for tuning in to Open Source Friday. Thank you for your support of open source. Don't forget, there is a 30% code at the beginning of the stream. You can rewind and take advantage of that code today and buy your tickets for GitHub Universe. If you are a contributor to this project, to the Julia Programming Language Project, and live in the San Francisco Bay Area, please send me a DM. I will put my X, which is unfortunately the hell I live in, but that's the easiest way to get a hold of me, in the chat. So if you have been a contributor to Julia, please send me a message. I want to meet you. I want to talk to you. I want to invite you to something. Take care, everybody. Take the rest of the day off. Thank you for being here. I'll leave you with, let's do this little jingle, which is one of my favorites. Speaking of the power of agentic workflows, right? This is our GitHub Copilot coding agent. And if you haven't downloaded and installed the GitHub Copilot CLI, give it a go. It's pretty good. Take care, friends.
I see it, I want it, I get it.